So welcome to the Model 6 RCM Management, and this model we are demonstrating how to manage the information that comes out from RCM. That means all the preventive maintenance that are defined, and how we collect this information, the importance of collecting this information in a process as parts of asset optimization and high performance achievement, and of course how to input this information in operation and maintenance routine. Okay, so we will see that there will be there is a strong link between RCM and asset management. And let's starting with a small demonstration that's how we link such preventive maintenance task to our routine operation and maintenance task activities and concerning asset management. So as described before, we have the asset management program flow, and that is support for reliability program. Okay, and we have defined activities throughout asset life cycle since the strategy definition and the assessments of feasibility of the process plants and their equipment, as well as during the concept phase, design, commission, operation. The most important things concerning RCM is that we starting to carry out some RCM analysis in the design phase, and during the operational phase, we get such information defined in the RCM include in our asset management in order to achieve high performance and keep such high performance along the operation. Okay, so RCM during the operational phase can also be reviewed and must be reviewed. Basically, it's not the maintenance test that was defined, but the frequency that they need to be applied. As we discussed before, the equipment get aged, and in some points the interval to perform some scheduled maintenance or predictive maintenance is getting shortened, and even we need in some point to define when to replace that equipment. But the focus here it will be to understand the link between the design and the maintenance policy defined in the RCM to the implementation of such preventive maintenance defining here in the asset management routine, and that means operation and maintenance routine. So again, the RCM management process has the main inputs, the information that comes out from the FMEA analysis. So again, we need to, in the very beginning, during the design phase, have an equipment list, define some criticalities. The equipment that have a level of criticalities need to be part of the RCM, need to be under FMEA scope. And of course, during perform the FMEA as we learned in the first day of this training, that we have different FMEA such as system FMEA, design FMEA, process FMEA, and FMEA. Concerning the FMEA, that we have failures triggered for wear out and degradation process triggered during operation. Some of them we are able to detect and prevent, and the ones that we are able to detect and prevent will be the main input for the RCM. So the RCM also get input from current maintenance information, and basically are the information that comes out from the manager, from the vendors, and also what's the current procedures and the knowledge that the maintenance specialists have. They bring everything to the RCM workshop, and then during RCM workshop we will define the maintenance activities. So we need to take into account the failures and maintenance that can impact on operation availability and reliability, and such failures need to be assessed in terms of quantitative analysis. So the RCM has a main input the female analysis, and the output of the RCM is the assessment of the impact of such preventive maintenance in asset performance. So as we discussed during the model 5, 4, and 3, the asset optimization means achievement, high performance achievement, and lowers life cycle cost achievement. So the RCM will have will be the input information for the the performance achievements, and that's is predicted based on the run analysis modeling. And for maintenance group, it will be run analysis in the equipment level, as we already demonstrated in model 3. Also, we need to consider the impact of life cycle costs concerning all preventive maintenance. That's what we discussed during model 4. And of course the spare parts, that is basically defined as also by based on preventive maintenance. That was discussed in model 5. So after all this information, the further step is try to optimizing all these preventive maintenance spare parts definitions to achieve high performance, and also achieve lower life cycle costs. Okay, and then we will have our reliability and operability and operational availability target, production efficiency targets, as well as our inspection and maintenance plan program. So the optimization by itself, to be optimization, needed to have some algorithm for behind that enable to arrange and define the arrangement of the time of the group of equipment or components, intervals of intervention, as well as the level of spare parts that maximize the performance, minimize the life cycle cost. This specific discussion about optimization is not the scope of this training, and is part of the ILS training, Integrated Logistics Support training. And of course, you can get more information or even attend the ILS online training. Okay, but it's important to understand that the optimization is not a different tryouts of implementation in run analysis, but the optimization having a specific algorithm that gets the best results based on the input information. And one of the output input for such optimization, other than reliability and maintainability analysis, are the preventive maintenance tasks. Okay, so we need to manage well such outputs that comes out from the RCM, as well as to input such information in the asset management that will be discussed in the next model, in order to guarantee that this optimized inspection and maintenance plan will be implemented. Uh, One very important point when we carry out RCM is to define priority when we have a plan. So we already discussed that when we presented the FIMEA, but for RCM is the same. So uh, there are two differences situation. One, let's consider one is the design, and during the design, we have a plan, and we need to define which are the most critical equipment. So this kind of critical assessment, the qualitative, can define based on different criteria such as safety, environmental, production, and cost, which are the ones that have more relevance, that are more critical. So we have a range, these criteria range from 1 to 5, and we have classification for 1 to 5, and we need to reading that and see which number we will put in here. In the end, here we have a criticality score for that's considered the highest number, aim on this criteria, and also the priority rank number, that's a multiplication of each one of these numbers here. Okay, and that helps to have some criticality and see which one are the most critical in terms of priority rank, so that's multiplication of the criteria, and look on which are the most critical item the ones that have a critical item and what is it related to. So in case of vessels, that's related to safety, and as well as for the compressors. So that's a big issue, and we need to considering also safety when you carry out the RCM. So the main idea here, when we have a plant, is to have a criteria to give a prioritization to carry out the RCM. Okay, so sometimes it's not clear how long does it take to carry out RCM for entire plants, process plants, and let's say that is real critical. Let's say that we can, in an optimal case, carry out a RCM for a pump concerning all the components in one day, and of course the other pumps in this process plant will be very similar, and the compressor, for a compressor, we need more than one day, 2 or 3 days to go through all this, the compressor, turbine, system, subsystem, and surrounding equipment. So for entire plants, we need sometimes more than 1 month, 2 months, 3 months. The point here is when we have a priority, in the end, if the project needed to be closed, or there's no much budget to invest on it, based on the priority, at least we carry out the RCM for the most critical equipment. Okay, that's we're talking about the design. The similar situation we can have in a plant that is not when we have a plant during in operational phase that is not clear which type of preventive maintenance need to be implemented, and in some cases some companies just implement what the vendor suggests, and after some time they see that this suggestion increase the operational cost. They have higher operational cost than expected, as well as have some impact on preventive maintenance. So they need, in general, to assess the RCM, the preventive maintenance for all the equipment, and what they're going to do to, as long as they make assessment, they starting to get some results. The way to do that is to define prioritization, qualitative prioritization, based on the specialist opinion, to define which are the most critical equipment, and starting to define preventive maintenance based on the RCM implementation for the most critical ones, and then go to other equipment that will impact on the cost and production and safety and environment. So and then we are starting to have some improvements based on RCM implementation that is based on the criticality. If mostly, in fact, mostly when we have a plant, process plant in operation, and some equipment, critical equipment, or equipment that's have some problems, and the preventive maintenance are not able to avoid this problem on time and in proper time, and you have a higher life cycle cost, operational costs in this particular equipment. And the first issues that is discussed is and questioning is the preventive maintenance plan. Maybe that's important also to say that maybe there is not an issue about the preventive maintenance, but the equipment quality and reliability by itself, and that will not be solved by preventive maintenance policy and task. But let's consider that's an issue about preventive maintenance. So it's clear that such equipment needs to when is not that there was no RCM carried out during the design. This equipment will need RCM to review this preventive maintenance, okay? And in during operational phase, that will be clear in many cases which are the critical equipment, which are the problematic equipment, which are the equipment that maybe needs more detailed preventive maintenance task, and the RCM will be clear for which equipment need to be under RCM scope. But even though we need to prioritize, and when you look on equipment, a pump is not a big issue, but a compressor, for example, or turbine, we have a lot of components and subsystem surrounding the compressor. So we need as well to prioritize the components that will be assessed during the RCM in order to get improvement along the RCM implementation. Okay, so this criteria is very important to define which one we start in our RCM concerning a plant's process. Okay, let's take a look on the software application. So software application, I give an example of Reliance of RCM, very good tools. In this tool, we have the female together with the RCM, so you can use this tool during your RCM workshop as was demonstrated in the first day of this training. Upload your female and inputs here the preventive maintenance task, and that we will have for each equipment. So let's get an example. The bearing, we have a sizing as a failure mode that will impact the bearing, and we as effect we have a low flow. This sizing is caused for high vibration, overloaded caused by high vibration, and then we define as a preventive maintenance a vibration online. So here we have in this diagram all the logic. We can also have a template that explain all this information. So what we'll define when we carry out the maintenance task? We define the type of a maintenance. Here you can see vibration online, the type, condition-based monitoring, and here we can, as long as it's online, there will not be a specific time to be carried out. But in terms of schedule maintenance, in terms of non-destructive tests that need to be performed in a specific period of time, we can establish here when we implement such preventive maintenance, schedule maintenance, non-destructive test, and how long does it take? Okay, we can define it here. For the vibration monitoring line, basically there will be no intervention, and the vibration when they achieve the threshold that can trigger some failure in the equipment, that indicates that the equipment maybe has a potential failure, and then the maintenance specialist you analyze, and if they agree that's necessary to make some intervention, they plan that. So here in this template, we can see in our RCM software solution that we can work during the female analysis, for example, in a template, as I mentioned before, during the workshop. And the most important thing is to have the link about the recommendation that comes from a female, as I mentioned before in our flow diagram of asset optimization. Such actions that some of them are related to procedure, but we can see that many of them are related to define preventive maintenance. Okay, so here we have a lot of training and procedures, but here we see that we define predictive maintenance to detect failure. And in this case, for example, we have a responsible for that. We have a plan to be completed. We have to also to implement some actions here regarding training, but we need to input such information in the system. So here is the female management, and then at some point when I implement this information in the system, means I will schedule my RCM workshop, and after the RCM workshop I will be able to check if what kind of preventive maintenance was defined here that mitigate this RPM number, okay, from 180 to 20. Okay, and here we can also see some recommendations related to implement RCM. So some failure modes, for example, implement training for a procedural lubrication is one action, but action taken is RCM analysis implemented also to define what kind of lubrication test or monitoring we're going to do. So RCM implementation is very important in one of the actions to be controlled when we implement that, to assure that we have the proper preventive maintenance task defined in order to avoid such failure mode. So that is the link between the FIMEA and RCM. Okay, and of course, if you look our our list of preventive maintenance defined in RCM, we have a list here that will show all the preventive maintenance, and we can take a look on it in details. What does it mean? Okay, RCM can also be input for CMMS Maximus. So based on RCM, you can use our Maximus system to input some information about the description of type of the maintenance, and also put the duration, all this information here. So it's a very used system to manage the RCM. Okay, it's important, as I already discussed in here, to have online monitoring and online integration of the maintenance and the equipment condition. And is important also, as we discussed before, if we have online vibration, for example, in this equipment here, in this compressor, in this pump here, we will be able to capture such vibration, and different specialists from the concerning operation, maintenance, and vendors are able to get the same information and discussion about the intervention that's needed for one specific equipment, and what type of root cause analysis that can trigger some failure modes. Okay, it's important to have on mind that maintenance management is not about asset management. So here we have our asset management inputs. So we have this equipment here that is related to inspection definition, such as visual inspection and ultrasonic test, that was defined during the RCM. And that is the main inputs that we will include on our asset management system. So that's, you can see a special register. They define, have reference numbers, have scope of work definition, and have this equipment description, have system definition, and have subsystem. So in subsystem, we can see that there is a defined inspection and the dates to carry out that. And you look on the status and anomaly. That's the type of routine that the maintenance group carry out during operation, and that's a link between. This link is needs to be established between what was defined in RCM and what will be implemented during the operational routine. So we can also the maintenance group also have the asset management scheduling that encompass the type of activities that need to be carried out for specific equipment. So here we can see we have a turbine, we have the reference and the type operator rounds that need to look on this turbine, and what they need to do in terms of inspection, and that means check condition of equipment and report any deterioration performance on condition, including internal visual check. So for the operator, he needs to have this routine and inform to maintenance group this type of information. And that's a type of test that in some case for critical equipment can also be defined during the RCM, and the frequency periodicity need to be defined as well. And that's all this information, this type of information that are defined in the RCM, and go to the asset management system, where the management the maintenance group can manage such information and implement. We need to be sure and clear that the maintenance management do not mean asset management. Asset management is something more robust than maintenance management, and encompass other issues related to performance monitoring, related to fracas, that is part of asset management. Okay, so in many cases, in process plants, the maintenance group understand that their maintenance activities is all about it means asset management at all. But that's not the truth. Asset management is more robust. That's maintenance management. Of course, asset management, maintenance manage all this maintenance task resource in a proper time in order to mitigate the impact and keep the equipment in a condition as good as new as much as possible is the key point of success, is a success key point and success factor for asset high performance achievement, but is not asset management. So we are going to see in the next model what we describe as asset management, and then we'll see, as I mentioned now, that of course maintenance management have a place a very important role in asset management and need to be very well defined. And the link for the first step to have a successful high performance achievement based on asset management and also based on maintenance management is to have a very well RCM results that can clearly define the equipment maintenance, preventive maintenance task that can support the system and physical asset to achieve high performance. Okay. So that's the end of this model. The objective of this model was to demonstrate the link between the RCM and the maintenance activities, the maintenance management as an input, how to manage the RCM concerning the outputs, concerning the inputs and outputs, and how important is the RCM and that in terms of as a first step for our maintenance routine or operational routine. Okay, the next model we will check the asset management, the relation between RCM and asset management. That's not only about the maintenance management. And then it will be clear the difference between maintenance management that we're discussing here with asset management. Basically, maintenance management, again, you have a list of preventive maintenance that need to be implemented. You have a resource that you can use, so you try to optimize such a resource and apply the best preventive maintenance that brings the system the best high performance and also the lower life cycle cost. Okay, so if you have any question, please send me an mail, and thanks again to attend this model.